So for this example, we are going to talk about the method of finding the equation of the perpendicular bisector of two given points on a rectangular coordinate plane. So let's try to look at the given information, that is the 2 points A 4, 2 and B 8 and 8. And for part A, we are going to find the coordinate of C, which is the midpoint of AB. So as we are given the two coordinates of the two given points, we can consider A42 to be x1, y1, and also B88 will be x2, y2. So in part A, as we are required to find the coordinates of the midpoint of AB, we can try to apply the midpoint formula, that is x1 plus x2 over 2, and also y1 plus y2 over 2, where the average of x1 and x2 would be the new x-coordinate of the midpoint, and similarly, the average of the original two y-coordinates would be the new y-coordinate of the midpoint. And then we can try to replace x1 by 4, x2 by 8, y1 by 2, and y2 by 8. And then find the result, and then we have 6, 5 to be the midpoint of AB. So in part B1, we are going to find the gradient, the slope of AB. And then in part B2, using the result of the part B1, we are going to obtain the gradient of the straight line, which is perpendicular to AB. So as we are already given the coordinates of the two given points, then we can apply the gradient formula, that is m equals to y2 minus y1 over x2 minus x1. Then we can perform the substitution. We can try to replace y2 by 8, replace y1 by 2, replace x2 by 8, and also replace x1 by 4. And then we have 8 minus 2 over 8 minus 4, such that it becomes 6 over 4. Then we will get 3 over 2. And then in part B2, we are going to find the gradient of a new straight line, such that that straight line is perpendicular to AB. So we are going to look at the relationship of the gradients of a pair of perpendicular lines. Then we can try to apply this trick, that is, we can try to use m1 times m2, which is equal to -1, where m1 and m2 are the gradients of the two lines respectively. For example, when we are going to find out m2 with the given m1, then we can try to make m2 to be the subject, that is m2 equals to -1 divided by m1. Then in this situation, we are going to use -1 divided by 3 over 2, which is the negative reciprocal. Then we will have -2 over 3. So lastly, for part C, we are going to find the equation of the perpendicular bisector of AB, and we have to present our answer in the slope-intercept form. So from the slope-intercept form, we know that we have to present our answer in the form y equals to mx plus c. And also for this question, as we are required to find the equation of a perpendicular bisector, that means we are required to find the equation of a straight line. So for this part, as we already know the coordinates of A and B, we can try to use a simple diagram to demonstrate the situation. That is, we know that A is 4, 2, we know that B is 8, 8. So those are the approximate locations. And as we already know that the midpoint of AB will be 6, 5. Somewhere here. So it is understandable that the midpoint of AB must be a point on the line segment AB. And at the same time, when we are going to construct the perpendicular bisector of AB, it must be a straight line such that it passes through the midpoint of AB. At the same time, it must be perpendicular to the line segment AB. And also we are given that the gradient of this solid line would be -2 over 3. Then in this situation, when we are going to find the equation of the perpendicular bisector, which means we are going to find the equation of a straight line, then one of the powerful tools we can use would be y minus y1 equals to m bracket x minus x1. So every time when we are going to use this approach to find the equation of a straight line, we always focus on the substitution of m, x1 and y1. So in this situation, you can see that negative 2 over 3 is m, and then 6, 5 will be x1, y1. Then we can simply consider m will be negative 2 over 3, and then replace x1 by 6, and then replace y1 by 5. So firstly, on the right hand side, we try to expand it such that it becomes negative 2 over 3x plus 4. And then we can try to present our answer in the form y equals to mx plus c. Then we can try to move the subtraction of 5 to the right such that it becomes the addition of 5. So 4 plus 5, that will be 9. Such that this one will be the answer, negative 2 over 3x plus 9. I would like to present the another way to find the equation of this perpendicular bisector. The another way is to start from the form y equals to mx plus c. As we are given that the gradient as well as the value of m is equal to negative 2 over 3, then we can try to replace m by negative 2 over 3 such that it becomes y equals to negative 2 over 3 x plus c. So from this formula, c is the y-intercept of this straight line. And in order to find this unknown y-intercept, we may have to use one of the fixed point on the straight line to find it out. So as it is given that the perpendicular bisector passes through the midpoint 6 and 5, then we can try to replace x by 6, and at the same time we can try to replace y by 5. And then we can try to consider the value of negative 2 over 3 times 6, which is negative 4. And then we can move negative 4 to the left, becomes plus 4. So we have 9 equals to c. If we get the y-intercept, positive 9, then we can make the conclusion. Therefore, we have y equals to negative 2 over 3 x plus 9 as well, which will be the same as the result of our first approach.